Everybody, Mr. Bowman here, another video on 3.14 probability distributions, and in this video we're focusing on all the merit questions for that 2020 exam. Only 3 of them, so let's get into question number 5, and don't forget all these questions are from the Quick Maths website, so do check the description to this video for the other excellence questions. So a hospital claims to deliver lunch, so they're delivering lunch from patients anywhere between 5 and 25, so that's minutes, the units, after the meal has left the kitchen. They also aim to deliver dinner anywhere between 5 and 30 minutes after the meal has left the kitchen. The meals are cold if they arrive more than 20 minutes after they leave the kitchen. Use an appropriate distribution models to calculate an estimate for the probability that a patient has cold lunch and cold dinner. So that's basically saying for lunch and dinner, we're trying to find the probability that X is greater than 20 minutes for lunch, and then for dinner, they've got different characteristics. So the first thing to note is the units, minutes, that's continuous data. So if you're dealing with continuous data, it can really only be triangular, uniform or rectangular distribution, or a normal distribution. That's kind of the limit of it. So this data, we're lacking a lot of information. So because we've got a minimum and a maximum, we know it can't be the normal distribution. And for a triangular distribution to be relevant, like you've got to have the peak, and we don't have the peak. So that probably means we're using a uniform distribution, and that means it's equally likely to come out from the kitchen anywhere between 5 and 30 for the lunch case. Oh, sorry, 5 and 25 for the lunch case, and 5 and 30 for the meal case. So hopefully that makes sense. That's why I'm thinking it's going to be a uniform distribution. So because it hasn't told me the distribution to use, it's really clear, it's really important. You should state the distribution you're using and then state any parameters that you're using as part of it. Because every so often they require that for the achieve criteria. So we're doing a uniform distribution for both lunch and dinner. So for lunch and dinner. Okay, so let's start off with the lunch one. So there's my x-axis and there's my rectangle. So I've got 5 to 25. So 5 is my minimum, which is the A value, and 25 is the maximum time, which is the B value. And we've been asked to find the probability anything more than 20 minutes. So let's do 20 over here, definitely not the scale. So we're trying to find this shaded probability here. So the way I do this, or rectangular probabilities, is you can find the height. You don't actually need to. So what I'm going to do is I know the total base. So let's go probability that X is greater than 20. It's going to be basically equal to the base of the shaded rectangle divided by the base of the big rectangle. So the base of the shaded rectangle is going to be 5, because that's the difference between 20 and 25. And then the whole rectangle is going to have a base of 20. So that means the probability that the lunch is going to be cold or above 20 minutes is going to be 1 out of 4. So I'm now going to replicate this for my dinner meal. That's between 5 and 30. So there's my x-axis. And there's my distribution, slightly longer because it's going from 5 all the way to 30. So 5 is my A value, which don't forget is my minimum. And 30 is my B value, which don't forget is my maximum. And my X value, the one I'm trying to find out, and that was 20, because we're trying to find the probability that something was over 20 minutes. So same deal again. So the probability that X was over 20 minutes for the dinner distribution. So same kind of approach. We're going to find the base of the smaller rectangle, which is the numerator, and we're going to divide it by the base of the larger rectangle, being the denominator. So the base of the numerator, difference between 20 and 30 is going to be 10. So that means my top number there is going to be 10. And down the bottom, between 5 and 30, that's going to be a difference of 25. So the probability that the dinner is going to be cold, or the dinner is going to be longer than 20 minutes before it leaves the kitchen, is going to be 2 out of 5. Now, I can't remember the marking schedule exactly, but if you got one of these 2 probabilities right, I'm pretty sure you got your achieved mark. If you then combined them to find the probability that both the lunch and the dinner are cold, you then get the merit mark, and that's the next step here. So we're going to go probability that they are both cold, that's going to be equal to the probability of the lunch being cold times the probability of the dinner being cold. So it's going to be 1 over 4 times 2 over 5. And this here is just unit fractions. You can bang this into your calculator, but let's do top times top, which is 2, bottom times bottom, which is 20. So we're going to have 2 divided by 20, which is going to get me to 0.1. Okay, we are now on to question number 6 from the website. So we've got the Ministry of Health recommending adults eat at least 3 servings of vegetables per day. Suppose that the number of serving of vegetables eaten by day can be modeled by a percent distribution with a lambda of 3.2. What would the value of lambda be under a percent distribution so that at least 95% of New Zealand adults ate at least 1 serving of that? So this one's a bit weird. Even though you're given lambda, you actually need to calculate this one. This is actually an inverse percent distribution question. So inverse percent distribution is kind of what we need to do here. So I always just state what I'm doing. Just a reminder, because every so often the marking schedules are weird and they just require random things. And one of the random things it might require is stating the distribution and what you're doing. So we're just going to do that. So I guess the first thing to note is inverse distributions only work when you've got the probability of x being equal to 0. So that's the probability of no vegetables being eaten by a certain person. And we're quite lucky. We've actually got this 95% number. So that number relates to, if you draw out a number line, so we've got maybe down here, 0, 1, 2, 3, 4, 5, 6, and then just so on. So that 95% says at least 1 serving. So we've got this number, which means we can work backwards to find out the probability of 0 by doing the 1 minus the probability trick. So the probability, back up the top here, the probability that x is equal to 0, that's going to be equal to 1 minus the probability that x is equal to or greater than 1. And we know that to be 95%. So that's going to be 1 minus 0.95, which is going to be equal to 0.05. So we're trying to use an inverse percent distribution question with 5% as the kind of probability parameter, and we're going to have to work backwards to find out that. So in an inverse distribution question, the probability that x is equal to 0 will be equal to e to the power of negative lambda. If you're not sure why that is, do let me know. I'm pretty sure I made a video about that and I can send you a link to it. And as I said, we calculated this to be 5%, so I'm going to get rid of that. So I know 0.05 is going to be equal to e to the power of negative lambda. And this here, I'm just going to bang that straight into the solver function on my graphics calculator. Again, I won't show you how to do that here, but if you want to figure that out, let me know. So when you put that into your graphics calculator, lambda is going to be equal to 2.996, and that there had a 3 dp rounding, which, because that's so close to 3, that's approximately equal to 3. And it's really important at this stage here. A lot of us stop there, which is most of the time fine, but I'll be really hesitant because inverse is always a merit question. Merit always means you're relating it to context, so there's some kind of contextual elements. So I would always suggest just put a little sentence at the bottom just to be sure. Say something like the mean number of servings per day is 3. So the average number of vegetable servings per day is needed to be 3. To be 3. There you go. So got that there. So yeah, most of the time, as I said, you're going to get the mark for that 3. But because it is a contextual or a merit question, there's normally a wordy element to the answer. So just put that in a sentence to contextualize your answer, just to be sure. And we are now on to question number 7. This is the last merit question for that 2020 exam. So it is estimated that the breakfast eaten daily by 99.4% of New Zealand youths. So we're given a probability. A year 13 student says approximately half of New Zealand youths eat breakfast daily. So 5 out of 10 of the next youth will eat breakfast daily. Comment on whether or not you think that's correct. So they've made the claim that exactly 5 out of the next 10 people, So if you think of a number line, so you got 1, 2, 3, 4, 5, 6, all the way up to 10. So they're commenting that exactly 5 is going to be that. So this here, I'm thinking it's going to be a binomial distribution question. So binomial distribution, and I'll explain how I got that shortly. So binomial distribution. So, and the main logic being is if you ate breakfast or not, that's kind of like a yes, no. That's like kind of discrete data. You can't kind of eat part of a breakfast. You either did or you didn't. And if you've got discrete data, it's either going to be a percent distribution or it's going to be a binomial distribution. And a percent distribution requires having an average or a lambda, and a binomial distribution needs a number of trials and a probability. So I was thinking that 10 would be the number of trials, and we're actually given a probability at 49.9%, so 0.499 would be that. So it looks like I've got all the inputs to a binomial distribution, and I don't have the inputs needed for a percent distribution. So just clearing that. So I know that n is going to be equal to 10 for my distribution, and I know my probability is going to be equal to 0.499. And I've been asked to investigate x equals 5 because they've said exactly 5 out of 10 students will eat their breakfast daily. So let's check if that's the case. So if I plug all of that into my graphics calculator, again, let me know if you need help doing that. I think I made a video somewhere about it. I'm going to get 0.2461, and that had a 4dp rounding. So that's all the math needed for this question. So the probability that of the next 10 youths coming by, the probability that exactly 5 of them are going to have their breakfast is 0.2456. So that's roughly 1/4, isn't it? Which, if you think about it, that's actually quite unlikely. So linking it back to the student, do we think the student's correct? Probably not in this case. I think 1 in 4 means, 3 out of 4 he's not correct. So this student is actually quite unlikely to be correct. In other words, I think he's going to have to be pretty lucky. If the next 5 out of 10 actually did eat their breakfast, they were quite lucky in that outcome. So let's just type up that response. So we can estimate the probability of 5 out of the next 10 youths having a daily breakfast to be 0.2461, or roughly 1/4. So it's just me explaining the number. Again, it's a merit question. It would be weird if they didn't have a wordy element to it. So let's put them in anyway. So this is fairly unlikely to occur, suggesting that the student is unlikely to be correct with their reasoning. And again, reasoning, the reason I'm using that word is because they've got the word in the question there. So I try to link my response with one of the words in the question. So that wraps up this question. Hopefully you found these merit questions useful from the 2020 exam. Keep an eye out for heaps more will be coming out, and hopefully you're finding them useful, and hopefully they're helping you out with your exam revision.